CLR1. So finally we can write it as in CLR1, if there is a RR conflict, if there is no RR conflict, but we may get RR conflict in LALR1. In CLR1, no RR conflict, even though there may be a chance, to get the RR conflict in LALR1. But in CLR1, no SR conflict and no SR in LALR1. If there is no SR conflict in CLR1, there is no SR conflict in LALR1 also. So that's why we can say that CLR1 is more powerful than LALR1 parsing algorithm, because CLR1 accepting more grammars than the LALR1 parsing algorithm. That's why CLR1 is more powerful than LALR1, sir. Suppose if you take two kind of grammars. One is ambiguous grammar. So these ambiguous grammars are not accepted by the bottom-up parsing algorithms. And coming to the another kind of grammars, those are unambiguous grammars. In these unambiguous grammars, most of the grammars are accepted by the CLR1 parsing algorithm. CLR1 parsing algorithm can accept most of the algorithms. But LALR1 algorithm can accept less number of grammars compared to CLR1. For example, here it is acceptable in CLR1, but it is not acceptable in LALR1. That's why we can say that the grammars which are acceptable in CLR1 may be not acceptable in LALR1. That's why CLR1 parsing algorithm is more powerful than LALR1 parsing algorithm. So CLR1 parsing algorithm is more powerful than LALR1 parsing algorithm, sir. LALR1 parsing algorithm. Next one is, for example, if we take the grammars, or if you take the all parsing algorithms, bottom-up parsing algorithms, we can write the statement as CLR1 is greater than LALR1 and it is greater than SLR1 and it is greater than LR0 grammars. So here CLR1 is more powerful than LALR1 and LALR1 is more powerful than SLR1 and SLR1 is more powerful than LR0 parsing algorithm. Here the power will be calculated based on the acceptance of the grammars. The algorithm which accepts more grammars is more powerful. The algorithm which accepts more grammars is more powerful. So with this statement, we can answer for some questions. With this single statement itself, we can answer some questions. So the previously asked question, one of the question is, which of the following statement is true? Which of the following statement is true? Option A, SLR parser is more powerful than LALR. And option B, LALR parser is more powerful than canonical LR parser. Option C, canonical LR parser is more powerful than LALR parser. And finally, the parsers SLR, CLR, and LALR have the same powers. We can easily answer this question, sir, by knowing this statement. Here, CLR1 is more powerful than LALR1. LALR1 is more powerful than SLR1, and SLR1 is more powerful than LR0. Here, the first statement telling SLR parser is more powerful than LALR. Wrong, because LALR is more powerful than SLR1. LALR is more powerful than canonical. Canonical is more powerful than LALR. It is also in the reverse. So that's why that is also wrong answer. And canonical LR parser. Sir, canonical LR means CLR. Canonical LR parser is more powerful than LALR. Yes, that is correct. That's why this is the correct statement. Sir, why not D? In D, they are specifying SLR, CLR, LALR are having the same powers, but the power of CLR1 is more than LALR, and the LALR power is more than SLR. That's why this is also not the correct option, sir. So by with this statement itself, we can get the questions in gate, sir. And one more question is also there. Which of the following statement? Which of the following statement about parser is are correct? Option A, CLR is more powerful than SLR. Option B, SLR is more powerful than LALR. And option C, SLR is more powerful than CLR. Option 1, A only. Option 2. Option 2, B only. Option 3, C only. Option D, option 4, B and C only. B and C only. So here also we know that CLR greater than LALR greater than SLR greater than LR0. So that's why CLR is more powerful than SLR. Okay, good, correct. SLR is more powerful than LALR. Not correct, because LALR is more powerful and SLR is more powerful than CLR. So SLR is less than LALR and less than CLR. So that's why this is also not correct, sir. So here the option 1, A only, CLR is more powerful than SLR. So you may get the questions on this area. So by giving the parsers in some order, they may ask which is correct and which is not correct. Like they may ask the questions, sir. They may ask the questions. And one more area. So these all things we have discussed, sir. LR0 parsers we have discussed, SLR1, CLR1 and LALR1. How to check the acceptancy of the grammar and how to check the given grammar is LR0 grammar or SLR1 grammar or CLR1 grammar or not, and LALR1 grammar or not, like that we have seen. And we have constructed parsing table for every parsing algorithm. And here the combination questions or comparison questions may ask like this. And one more thing is relation. Before this one, the relation based on the powers, but now the relation based on number of states. So the relation based on the number of states for LR0 and SLR1 and LALR1 and CLR1. If we see the relation, the number of states in LR0, the number of states in SLR1, the number of states in LALR1, all are equal. The number of states of LR0 and the number of states of SLR1 and the number of states of LALR1, all are same, sir. But the only difference is in CLR1, the states may be greater than or equals to LALR1 or SLR1 or LR0. So this is the statement we need to remember to answer some kind of questions. So they may ask relation based on the number of states. So one more previously asked question based on the number of states is consider the grammar S derives open parenthesis capital S closed parenthesis /A. This is the grammar, sir. So next, let the number of states in SLR1, CLR1, or and LALR1 parses LALR1 parses for the given grammar, for the given grammar B N1, N2 and N3 respectively. The following relationship holds good. That means which relationship is correct. Which relationship is correct. Here, what he is saying is there is a grammar and there are 3 parsing algorithms. They constructed LR0 or LR1 DFA. By constructing DFAs, the number of states in SLR1 is N1, the number of states in CLR1 is N2, and the number of states in LALR1 is N3. So which relationship is correct, he is asking. Option A, N1 less than N2 less than N3. Option B, N1 equals to N3 less than N2. And option C, N1 equals to N2 equals to N3. And option D, N1 greater than or equals to N3 greater than or equals to N2. So these are the relations mentioned here. So which of the relation satisfies this rule? N1 less than N2. Okay, because SLR1, number of states in SLR1 may be less than CLR1. So here it is the SLR1 number of states and N2 is CLR1 number of states and number of states in CLR1, and these are the LALR1 states. So CLR1 holds more number of states than SLR1. So that's why up to here it is okay. But LALR1 holds greater number of states than CLR1. Here it is not satisfying. So that's why option A is not good. Option A is not holds. And coming to the option B, N1 and N3 are equal. N1 means SLR1, N3 means LALR1, because the order is SLR1, CLR1, LALR1, N1, N2, N3. So the number of states in LALR1 is N3 and the number of states in SLR1 is N1. So SLR1 should equals to the number of states in SLR1 should equals to the number of states in LALR1. Okay, it's good. And the number of states in CLR1 may be greater than the N3. Maybe greater than the N3. Most of the cases, the number of states in CLR1 is greater than the LALR1. And one more thing is, all our programming languages, C, C++, Java, all these compilers are using LALR1 parsing algorithm, because in CLR1, if we are having 10 states, in LALR1, the number of states are 5. And suppose if it contains 2, here the number of states are 4. So most of the cases, double number of states exists in CLR1. That's why it is greater than. So it is somewhat correct answer. And coming to here, see, N1, N3 both are equal, okay. And N2 is also equal. You may ask, sir, sometimes it may be equals to LR1. It may be equals to LA LR1. So that's why it is not correct, sir. But suppose if you take this consideration, most of the cases, the number of states in CLR1 and the number of states in LALR1 there is a huge difference. That means half of the number of states reduced in LALR1. So that's why this is not the chance to equal to the LALR1. So this is the good option, which is here also, question also, the following relationship holds good. So that's why for this conversation, we can say that, so B is the option. And coming to the N1, N3 and N2, it is not correct because N1 is greater than N3. CLR here, if we compare CLR, SLR1 having more number of states than the CLR1. It is not a correct comparison, sir. That's why it is also not correct, sir. So here you may are having that confusion between these two. For reducing or for eliminating that confusion, I am giving an example. Most of our programming languages are using LALR1, even though CLR1 is more powerful than LALR1. All the programming languages are using LALR1. Why? Because the number of states in LALR1 is less than the number of states in CLR1. So our in design analysis and algorithms, you may see space complexity. So the memory required to store and execute the program is called as space complexity. So memory consumption is also the criteria of the algorithm. So that's why always we see which takes the less memory and which satisfies the same thing. In the same manner, most of the algorithms which are accepted by the CLR1 are also accepted by the LALR1. Only the grammars which are having RR conflict, other than the grammars which are having RR conflict, all the other grammars are accepted by the LALR1 parsing algorithm. That's why we are using, or many programming languages are using LALR1. So for this conversation, we can give the option B is the correct answer. Option B is the correct option. So based on the relationship, they may ask the question, sir. So this is the way. And one more question is also there, sir. One more question is also there. Among SLR, CLR, LALR, which of the following pairs identify the method that is very easy to implement and the method that is most powerful in that order. among SLR, CLR, LALR grammars. By taking these three grammars, which grammar is very easy to implement and which grammar is most powerful? That is the question, sir. Which grammar is very easy to implement? Sorry, which algorithm is very easy to implement and which algorithm is most powerful? The options are SLR, LALR, and option B CLR, LALR, and option C SLR, CLR, and option D LALR, CLR. So here we need to satisfy two things here. First one is very easy to implement. Very easy to implement. Which algorithm is easy to implement? So I can say SLR, one parsing algorithm is easy to implement because in CLR and LALR we need look ahead symbol. We need look ahead symbol for construction of DFA. But coming to the SLR, only LR0 item is sufficient. Look ahead symbol is not required. In that criteria, I can say that SLR is simple, is easy to implement. So SLR is easy to implement. Okay. So which is the most powerful method? Which is the most powerful algorithm? So already we know that LR0 less than or else CLR greater than LALR greater than SLR greater than LR0. So that's why CLR1 or CLR is the more powerful or most powerful. So easy to implement SLR. After that CLR. So here SLR is there, but LALR other CLR is more powerful than LALR. That's why it is not correct. CLR is more powerful, okay, but LALR the simplest. Here he mentioned in that order also. So that's why here SLR is not there and order is also not correct. So here also SLR is not there, sir. So that's why SLR is easy and CLR is most powerful. Is most powerful than all other parsing algorithms. All other parsing algorithms, sir. So one more question, sir. 2 marks. It is asked for 2 marks in previous GATE examination. An LALR1 parser for grammar G can have SR conflict. An LALR1 parser for the grammar G can have SR conflicts. SR conflict if and only if option A, the SLR1 parser for grammar G has SR conflict, and option B, the LR1 parser for G has SR conflict, and option C, the LR0 parser for G has SR conflict, and option D, the LALR1 parser for G has reduce conflict. So this is the question, sir. An LALR1 parser for a grammar G. One grammar is there. The name of the grammar is G. By applying LALR1 parsing algorithm, it may can have SR conflict. SR conflict. When LALR1 can have SR conflict, if and only if SLR1 parser for G has SR conflict. Actually, there is no comparison between LALR1 and SLR1 because here there is a look ahead symbol, but here there is no look ahead symbol directly. By using the follow, there is a look ahead symbol. That's why only we are writing SLR1 here, but there is no look ahead symbol at the expansion of the DFA. That's why this is LR1 items. So there is no comparison. That's why we can say that. So SLR1 comparison of SR conflict of SLR1 is not required. And coming to the LR0, so it is also not required because here also there is no look ahead symbol. Here also there is no look ahead symbol. And the last one is the LALR1 parser for G has reduce. For getting SR conflict, it is not required. Reduce conflict is not required. But if there is SR conflict or RR conflict, we can say that that is not the LALR parser. Sorry, LALR grammar. But it is not mandatory for getting SR conflict in LALR1. Sir, what about LR1 grammar? Up to now, we saw LR0 parsing algorithm, SLR1 parsing algorithm, LALR1 parsing algorithm, and CLR1 parsing algorithm. Sir, what is LR1 parser? LR parser is the another name of CLR1. Default name for CLR1 is LR1 parser. LR1 parser. So CLR1 or LR1, both are same, sir. So we are constructing LALR1 from CLR1. So and initially we discussed when there is no shift reduce, when there is no shift reduce in CLR1, there is no shift reduce in LALR1. When there is a shift reduce conflict in CLR1, then only shift reduce in LALR1. Then only shift reduce in conflict in LALR1. So we can say that the LR1 parser for G has SR conflict, then only we can have the conflict of SR in LALR1. So option B is correct option, sir. Option B is correct option. Because if there is a SR conflict in CLR1, then only the same conflict will come in LALR1. Otherwise, LALR1 does not get SR conflict without the conflict exist in CLR1. So that's why option B is the correct option, sir. Option B is the correct option. So this is about bottom-up parsers. Till now, we have discussed bottom-up parsers. bottom-up parses, there are two types of parses are there. One is LR parses, another one is operator precedence parser, operator precedence parser, and LR parses. Coming to the LR parses, we are having LR0 parser, SLR1 parser, and CLR1 parser, and LALR1 parser. So these four we have discussed, sir. Almost 15 hours I have taken for discussing these four algorithms and construction of the parsing tables and finding the grammar is LR0 grammar or not, SLR1 grammar or not, CLR1 grammar or not, and LALR1 grammar or not, and how to check the acceptancy of the grammar or the string. Is the given string is accepted by the SLR1 or not, and CLR1 by or not, and LALR1 or not. And we have discussed shift reduce parsing algorithm also. Shift reduce parsing algorithm also. And we have discussed every comparison and the differences between every parsing algorithm. What is the difference between LR0 and SLR1? What is the difference, or what are the drawbacks in SLR1? How we are overcoming those drawbacks in CLR1, and what are the difficulties in CLR1? How we are overcoming those problems in LALR1? Everything, the advantages and disadvantages, and what are the difficulties are there in every parsing algorithm we have discussed. So now the next topic is operator precedence parsing algorithm, or operator precedence parsing algorithm. So operator precedence parsing algorithm is also the shift reduce parsing algorithm. Operator precedence parsing algorithm. Operator precedence algorithm is also shift reduce parsing. Shift reduce parsing algorithm. Shift reduce parsing algorithm. And the major difference and the major requirement is operator precedence parsing algorithm. Operator precedence parsing algorithm is also used for accepting ambiguous grammars. All the LR parses does not accept ambiguous grammars. Ambiguous grammars are not accepted by LR0 parsers. Coming to the operator precedence parser, it can accept ambiguous grammars are also ambiguous grammars also. And third one is operator precedence parsing algorithm is easy to implement. Compared to remaining LR parsing algorithms, it is easy to implement, sir. It is easy to implement. And one more point is operator precedence parsing algorithm. Operator precedence parsing algorithm accepts special grammars, special kind of grammars. Those are operator grammars. So here there are four points I have discussed. One is operator precedence algorithm is also called as shift reduce parsing algorithm. Why we are calling this one as a shift reduce? I will discuss that. And second thing is it accepts or it can parse the ambiguous grammars also. It can parse the ambiguous grammars also. And it is easy to implement. Sir, how can you say easy to implement? So I will explain that point also. And finally, what is operator grammar? When we call the grammar is operator grammar. So every grammar is in the format of alpha derives beta, where alpha is maybe single non-terminal or anything. Based on the grammar, it will change. For regular grammar, it is different, and for context-free grammar, it is different, and for context-sensitive grammar, it is different, and for recursive enumeral grammar, it is different. Sir. So coming to the operator grammar. So how can we represent operator grammar? So I will discuss it. Actually, in the operator precedence parsing table, no shift and reduce actions are included. Shift and reduce actions are not included in the parse table. But by using the table entries, we perform shift action or reduce action. By using the table entries, we perform shift action or reduce action. If you see stack, initially it is dollar, and the top of the stack is, suppose if it is X, initially there is something, and Y or else ID plus ID star ID dollar. This is the input string, and operator precedence parsing algorithm, and this is parse table or operator precedence parse table. X, Y, Z dollar, X, Y, Z dollar. So we can write it as sum less than, greater than, less than, greater than, accept, like. So this one. Here, like as LR parsing algorithm, we are having two parts. One is algorithm, another one is table. So we also understand two things. How to construct the table, that is the one part. Another part is how to execute the algorithm. So one thing is how to construct the table, and second thing is how to execute the algorithm. So in the execution of the algorithm, so shift action means we move to the stack. For reduce action means we use the table. For reduce action, we use the table. For shift action, we use the stack. So that is depends upon the shift and the reduce actions are depends upon based on the table entries. In the table entries, some operators are there. The operators are less than, greater than, equals to, like. Less than, greater than, or equals to, like. So here, the first point is operator precedence parsing algorithm is also the shift reduce parsing algorithm. Sir, why we are calling that one as a shift reduce parsing? Because there is no entries in the shift and reduce entries in the table. Even though there is no shift and reduce actions in the table, for the operator symbols which are existed in the table will perform shift action and reduce action. Shift action and reduce action. That's why we are calling operator precedence parsing algorithm is also shift reduce algorithm, because the operations are performing. Shift operation is performing and reduce operation is performing. And second point. So hope you understood this point, shift reduce. And second point is ambiguous grammars. So we have the clarity on the grammar. So the grammars are two types. One is unambiguous grammars, another one is ambiguous grammars. So unambiguous grammars means we can construct LMD or RMD. By constructing LMD or RMD, we'll get single parse tree. Single parse tree. In the ambiguous grammars, we may get different parse trees. We may get different parse trees for LMD or RMD or two LMDs or any two RMDs. We may get two different parse trees. So in the previous LR parsing algorithms, we can't accept the ambiguous grammars. But coming to operator precedence parsing algorithm, it can accept ambiguous grammars as well as unambiguous grammars as well as ambiguous grammars also. And one more thing you need to remember is it is undecidable. It is undecidable. Sir, why you are telling undecidable? Because operator precedence parsing algorithm can accept some of the ambiguous grammars, but not all. Because we don't have any proper algorithm for this. We use trial and error method. With that method, it can accept some grammars. Which are not accepted by the LR parsing algorithms. And second point is also clear, sir. First point is it also you call as shift reduce parsing algorithm because it uses shift and reduce operations for the table entries. And second one is it also used for acceptance of the ambiguous grammars because till now LR parsing algorithm accepted the strings of unambiguous grammars. And the third point is easy to implement. Because if you see here, in LR parsing algorithm or LR parsers, the parse table is two parts. One is action part, another one is go to part. But here there is no differentiation. Only one table is there. So there is no action part. We can't say there is no action part. This is the action part only. But there is no go to part. That means there is no separation. Separation is not required. That's why we can easily construct the table. We can easily construct the parse table. In that criteria or in that situation or in that manner, we can say that is easy to implement. Because parse table is more important for checking the grammar is accepting the particular string or not. So for that purpose, without table, so by using the DFA, we have calculated and we did some sums, but table is required. But for doing gate examination questions without writing the table, also we can answer the questions. So right. And next one is accepts special kind of grammars. That grammar is called as operator grammar. So what is operator grammar? What is operator grammar? Operator grammars. Operator grammar. Any grammar is said to be operator grammar. First of all, it should be context-free grammar. The first point is it should be the context-free grammar. Context-free grammar means it should be in the form of alpha derives beta, where alpha is the single non-terminal and beta is the combination of non-terminals and terminals, or we can say easily any combination of terminals and non-terminals. Any combination of terminals and non-terminals. So, first of all, the grammar should be the context-free grammar. First of all, the grammar should be the context-free grammar. And the second point it has to satisfy is no epsilon productions are allowed. No epsilon productions are allowed. It should not contain epsilon productions. Operator grammar, it should be the context-free grammar. In the context-free grammar, it should not contain epsilon productions. It should not contain epsilon productions. Sir, what are epsilon productions? A derives epsilon, B derives epsilon. All these kind of productions are not allowed in operator grammar. And second point and third point is no adjacent non-terminals. No adjacent non-terminals on RHS. That means right hand side of the production should not contain consecutive or adjacent non-terminals. So if any grammar is said to be operator grammar, first of all, it should be the context-free grammar. After it is a context-free grammar, we need to check, is there any epsilon production? If there is epsilon production, that is not the operator grammar. So that means epsilon productions are not allowed in operator grammar. And then we need to check one more property. That property is no adjacent non-terminals on the right hand side of the production. No non-terminal productions on the right hand side of the production. So suppose if we take some examples, S derives AB, A derives small a, B derives small b. B derives small b. Is it an operator grammar or not? So first of all, we need to check it is the context-free grammar or not. Yes, it is a context-free grammar. All the productions are having single non-terminal on the left hand side and a combination of terminals and non-terminals on the right hand side. So that's why it is a context-free grammar. Okay, CFG satisfies. And is there any epsilon productions? No epsilon productions. Epsilon productions are not there. And is there any adjacent non-terminals? Yes, having adjacent non-terminals. Capital A, capital B. That's why it is satisfying. So it is also satisfying. It is not satisfying. It should not contain it is not, it should not contain adjacent non-terminals, but it is having, that's why these two properties are okay, but this property is not satisfying the according to the rule. That's why it is not operator grammar, not an operator grammar, not an operator grammar. So suppose if you take another example, S derives A, small a, B, capital A derives small a, capital B derives small b. Here I have included small a. I have included small a between two non-terminals. So these two are not adjacent. So this is operator grammar. This is operator grammar. And if you take one more, S derives capital A, small b, capital A, small capital B. A derives epsilon, B derives small b. No consecutive, no adjacent non-terminals. So that is satisfying. And it is a context-free grammar. It is also satisfying. But epsilon production is not satisfying because there is an epsilon production. So if any grammar is said to be operator grammar, the grammar has to satisfy some rules. First of all, it should be the context-free grammar. And secondly, no epsilon productions are allowed. And thirdly, no adjacent non-terminals on RHS of the production. So these are the things need to satisfy for operator grammar. So if we see a question, which of the following is not operator grammar? Which of the following is not an operator grammar? Option A, E derives E plus E slash E star E slash A. Option B, E derives E plus T slash T and T derives T star F slash F and F derives small a. And option C, E derives E plus N and E derives N star N. And option D, none. Sir. So which of the following is not an operator grammar? Which of the following is not an operator grammar? This is the non-terminal, this is the non-terminal. Between the non-terminals, there is a terminal. This is the non-terminal or non-terminal. There is a terminal. This is the terminal. So no two consecutive non-terminals are there. And there is no epsilon productions. So it is the operator grammar, sir. It is the operator grammar. And now coming to here. So it is the non-terminal, Between these two non-terminals, terminal is there. This is non-terminal, no consecutive extra non-terminal. Non-terminal, and there is a terminal. Only one non-terminal, terminal. So it is also OPR. Operator grammar. And coming to here, it is the capital, that means non-terminal, and this is the terminal, and this is also a terminal. And again, there is no adjacent non-terminals on right hand side. And here everyone is a terminal. So that's why it is also the operator grammar. So all are operator grammars. That's why in the question he is asking which of the following is not an operator grammar. So all are operator grammars. That's why option none is the correct option. Option none is the correct answer. So this is the way to find the given grammar is operator grammar or not. You may get the questions, 1 mark questions for checking the given grammar is operator grammar or not, sir. Operator grammar or not. And so the 4 points are completed, sir. The 4 points are completed. Shifted is completed. Ambiguous are not completed. Why we are calling this one is easy to implement completed. And is the given grammar is operator grammar or not? Operator grammar or not is also why when we call the given grammar is operator grammar, and when we call that grammar is not an operator grammar is also completed. And coming to next slide. So we know about the stack, sir. So stack is nothing but a data structure which uses a method LIFO. All the insertions and the deletions are performed at one end. The insertions are called as push and the deletion operations are called as pop. So this is about stack. So this stack is used to tell the acceptance of the grammar or a string, which stack is used to tell the acceptance of the grammar. So right, and next one is this is the input string or input buffer. It holds the string. Input buffer, it holds the input string, and always it ends with dollar, and initially the stack is having dollar. If the top of the stack is with dollar, that means stack is empty. So these two things are clear. Sir, what about operator precedence parsing algorithm and how it will work? How it will work? It will work by reading a look ahead symbol, and by considering the top of the stack symbol, it performs an action. That action may be shift, or that action may be reduce, or that action may be accept. Otherwise, the action may be error. Otherwise, the action may be error because after performing parsing algorithm, we'll get the parse tree. Or syntax tree, because we are discussing syntax analysis, sir. In the syntax analysis, the responsibility of the syntax analyzer is taking the lexemes from or tokens from it takes the tokens from lexical analysis, and by using context-free grammar and push-down automata, it produces parse tree. In the another case, if it is not able to produce the parse tree, it produces error or simply syntax error. We can say that is simply syntax error. For producing parse tree or syntax error, the parsing algorithm is using parse table, stack, and input buffer or input string. So how it works? The algorithm for operator precedence parser is, if X is the topmost terminal symbol of if X is the topmost terminal symbol of stack and Y is the look ahead symbol, then option one, x less than y, x less than y, or x equals to y, then perform shift action. And second one is x greater than y, then perform reduce action. If x comma y equals to, if x comma y, pt of x comma y, past table of x comma y equals to accept, then we can say that success or successfully string accepted. And fourth one is if pt of x comma y equals to blank, we can say that error. To specify x of y equals to accept or blank. So these two are specifies our answer, or specifies parse tree or this one. To give these two, it is doing shift and reduce actions. When we are doing shift action, if x less than y and x equals to y, in these two cases, we are performing shift action. If x greater than y, in this case, we are doing reduce action. So what is reduce and what is shift? What is reduce and what is shift? Yes, sir. If you please come to here once. Here, what I am saying, x is the topmost terminal symbol. X is the topmost terminal symbol of stack, and y is the look ahead symbol. X is the look ahead symbol. For example, here it is x and it is z. So what is the symbol here? X greater than z. X greater than z. This means we need to perform reduce action. Or else, suppose here top of the symbol is z, and here the look ahead symbol is x or y. For example, y. X less than y. In this case, we perform shift action. Shift action means we need to what we have to do is we need to push the non-terminal symbol. To the stack and increment the look ahead symbol. So shift operation means first point what we need to do is push y. Already x is in the stack, sir. Y is the symbol which we are reading from the input buffer. We need to push y into stack, first point, and then second point, increment the look ahead symbol. So these two things we need to perform when we need to perform the shift action. Sir, what about reduce? Reduce means replacing the handle by non-terminal. So by doing an example, you can easily understand these things, how to reduce and how to perform shift operations, and for doing an algorithm and for doing steps, we need to follow these four steps. If X is the topmost terminal, don't forget it, sir. Don't forget it. If X is the topmost terminal, suppose if the stack is like this, plus capital X or capital E. So this is the non-terminal. We should not consider this one. We should not consider this one. We need to consider the topmost, the top. Now we are not specifying the top of the stack, topmost terminal. So in the given stack, we need to check what is the topmost terminal existed. So I will explain you, sir, in the examples. So how we need to consider if the top of the stack having non-terminal, what the symbol we need to consider as a terminal and what we need to perform. You just please remember these steps. It is also very easy, sir. If X is less than Y or X is equals to Y, then shift operation we need to perform. At the time of greater than, we need to perform reduce operation. At the time of less than and equals to, we need to perform shift operation. At the time of greater than, we need to perform reduce operation. So this is for today's class, sir. So in the next class, I will explain you by taking some examples how to construct the table and how to check the given string is accepted by the given grammar or not. So for the operator precedence parsing algorithm, I will explain you how to construct the table as well as how to check the given string is accepted by the grammar or not. Sorry, sir. Accepted by the grammar or not. And how to check the ambiguous grammar is accepted by the operator precedency grammar also. I will explain in the next class, sir. I'm closing this session, sir, for today. Thank you.